Hi, children, and anybody else paying attention. Oh, good morning. It's just turned 6 o'clock. Oh, my goodness. Oh, I wish I could just use my computer. Okay, it just turned 6 o'clock, so I'm wide awake. I've been up for like a half an hour. You know I made my coffee, because I gotta have that. Okay, welcome to my world. My eyes aren't awake yet, though, but I am videoing, so I don't know why. 6 o'clock, it's like late. I slept in this morning. Anyway, my name is Mr. Krause, but for the next, few minutes, or however long you share with me, you could call me Mr. Key. All of this information can be found at www.nkinfinity.com. N stands for Newman, that's my partner in crime. K stands for Krause, that would be me. And infinity is just really cool, because we like to give lots of homework. It just never ends. This is the class that never ends. It goes on and on, my friends. All right, hopefully your teacher or you have given this assignment out. We're going to go over it, take some notes with it, see how we do, and then we'll move on. All right, so this first one, really quite simple. All I'm asking you to do, a little warm-up, a little 9th grade warm-up. I'm asking you to graph these two things. You see that the slope is 1/2. You see that the y-intercept is 0, -4. We'll graph that, 0, -4. And I know you're all going to start laughing at me about my was it 1/2? My great drawings on this system I have. Going up 1 and over 2, we'll reverse that, go the other direction. I have to put these points in, otherwise, first of all, it looks sloppy, and second of all, it's going to be, oh yeah, that's not bad. Oh, that's not bad. That's not bad. Hopefully it's correct. All right, and the next one, let me change colors. My slope is -3, that'll be coming down, and I have a y-intercept of 10. So 0, 10 would be this y-intercept. I think 10 is way up here. So 10's right here. Now, good thing is it's down 3 to the right 1, down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. Oh, looks. That's probably their point of intersection. Probably, Krause. That's definitely their. Now, this one will never get good because it's coming down. Oh, my gosh. All right. So clearly I'm drawing. Okay, use a straight edge. I can't use a straight edge because I don't know where to put the straight edge because I'm writing on the table and never mind. Anyway, so there I have those graphed, and now I want to try to answer these questions. First question is, for what values of f of x equal g of x? What they're asking for here is where do they intersect? Where do they intersect? For what values of x? Now notice I'm only asking for the x value, so I come back up here. Now I might be smart. If I'm smart, I might come by and say, okay, this is 1, 2, 3, 4, -2. This is the point 4, -2. But it says for what value or values of x. So this one is just x equals 4. He said, for what values of f does f of x equal -6? Well, what I probably failed to do, and now I did it sort of on purpose because I'm not just looking at these things, I'm not really sure which one's f of x and which one's g of x. So probably what I need to do is go back, say, okay, you're f of x, and you are g of x. And now it'll be a little bit easier for me to answer that question. Dunkin' Donuts K-Cups. Can't be anything better. So what values of f x does f of x equal -6? Now, what does this really mean? This really means we're looking for a y value of -6. A y value of -6, and we want to know what the x value is. All right, so we need to find a y value of -6 on the f line. So this is -1, -2, -3, -4, -5, -6. So there's f -6. Well, there's where y equals negative 6. Well, now I got to go over to the F one. There it is, right there. There is the point where the y value is negative 6. And if I just went like this and told you what that point is, it'd be 1, 2, 3, 4. So it'd be negative 4, negative 6. So the answer to this question is x equals negative 6. All right, so for what values of f of x greater than g of x? So what it's saying in this one, and you have to be able to read what it says, is when are the y values of this bigger or greater than the y values of this function? Now, by greater than on a graph, we mean above, right? So, because if I took this y value, the y value here is negative 2. What's the y value here? Oh, it's 3. It's above. So when I'm talking about greater than, I'm talking about above. So the question says, I got to go back and read it. When is f of x greater than g of x? Or in other words, when is f of x above g of x? Well, it should come as no surprise. This is the point where they're equal to each other. So that should be the cutoff point. So if I go to the left, if I travel to the left here, this way, isn't the purple line above the orange line? Or in other words, isn't g of x above f of x over here? When I go to this side, when I go this way, f of x is up here and g of x is down here. So starting at this point right here and going in this direction, f of x is above g of x. And that point, and remember, anytime you're going to give values, a range of values or domain of values, you want to use x values. Just lost my line. That kind of stinks. Totally, I'm going to need that. All right, so right here is, we said, was 4, right? So if that's the break off. If I go this way, the orange line's above. F of x is above. If I go this way, the purple line's above. G of x is above, or G of x is greater. So we want to go to the right, because they're asking, when is f of x above g of x? And so that would be when, and it says, well, for what values of x? X is greater than 4. Now I can't say equal to, because this does not have an equal to sign, so it just said greater than. This one always seems to confuse kids. For what values of f of x is there that g of x minus f of x is equal to positive 7? What we're looking for is when g is 7 units above f. Now, why above? Well, because if it's above, it's greater than. If I take a big thing and I subtract a small thing, I get something that's positive. If I take a small thing and I subtract a big thing, I get something that's negative. So I need to know when g is above f, 7 units above. So what we'll do is we'll come back over here and erase my other mess that I have here. Does your eraser work like that on your paper? All right, so let's take a look at this graph. I don't want to know what just happened. Went to yesterday's stuff. What I'm trying to do is, there we go. All right, so notice at this point, how far above is it? Let's see. Well, I don't even know. 1, 2, 3.5. That ain't it. And this point, 1, 2, 3, 4, 5, 6. Oh, 7. There it is right there. This distance here is 7 units. This is where it's 7 units above. So for what value of x? X equals 2. And finally, the average rate of change of f of x and g of x on from 0 to 5. Okay. So I need to find, and remember, we're going to do f of 5 minus f of 0 all over 5 minus 0. This is for the average rate of change for f of x. Well, f of 0 is easy. F of 0 is just negative 4, because if you were to plug 0 in there, you'd get negative 4. So, remember, we sub in using parentheses. 5 minus 0 is just 5. All right, so this is negative 4. Now I got to find f of 5. Let's see, this was, let's see, 1, 2, 3, 4, 5. So that's negative 1.5. So negative 1.5 minus 4, well, that's really plus 4, is really equal to 2.5 all over 5, and that's just 1/2. Now that should be obvious because we talked about it before, that on a linear function, the average rate of change will just be the slope. Now I can verify that one more time. We're going to do the g of x. I'll do it in a different color though. We'll go with black. So g of x, we're going to do g of 5 minus g of 0 all over 5 minus 0. By the way, how you like that logo? It's pretty cool, huh? Well, g of 0 is pretty easy. That was 10. I don't know g of 5. Let's see, g of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 5. Oh, I didn't do use parentheses. Negative 5. All over 5 minus 0, which is just 5. So this is negative 5 minus 10, which is negative 15. All over 5, which is negative 3. So the average rate of change for a linear function, it's always just going to be the slope. All right, kids, I'll be back. All right, here we go. Wait a second here. Which one's which? I can't tell. So it looks like we have an absolute value function, and you should know that an absolute value function looks like a V, and a linear function just is a line. So, okay, we can tell which one's which. So let's label those. This is h of x, because it's going to be kind of important you understand which one's h of x, and then which one is going to be m of x. All right. For what values, what value or values, that should be an S in there like that, of x does h of x equal? Remember, when they were looking for equal, we're looking for intersection. Where do they hit each other? And that's at this point right here. All right, so what value of x? X equals uno. Okay, for what value, see there, I did it right. And this one I didn't do it right. I got to fix these. Of x, does h of x equal 4? Okay, so h of x, remember, this is the y value equal to 4. So here's 4. Here's 4. All right. So for what value or values of x does h of x equal 4? Well, it equals 4 right there. So that's, but it also equals 4 right here. So it's got two values of x. It's got two values of x where h of x is equal to 4. So I'm going to put those in curly brackets. 1 and 3, right? So right here at 1, it's 4. And right here at 3, it's 4. I'm going to get rid of those so they don't cause too much of a mess. For what values of x is h of x greater than m of x? So remember, greater than graphically means above. So we're looking to find, now h of x is the gray one, and m of x is the black one. So we're looking to see when is gray above black. And that would be all here. This is where it's above. Right? Because it's all above all of this stuff down here. So from this point on, 1 is the breakoff point. From this point over, gray is above black. So when x is less than 1. Another way to say that, if you wanted to do it in just a little practice with, I'm going to make sure my big head's not in the way on these, with interval notation, and that would be from negative infinity to 1. If you wanted to practice with some interval notation. Okay, the next question says, for what values of is h of x minus m of x equal to 2? So we want to know when h of x, because it's positive, has to be above m of x by 2 units. So when is gray above m by 2 units? Let me get rid of a lot of this stuff. Okay, so 2 units. So here's where they're equal. So here, right here, boom, boom. See how they're 2 units away from each other? And the h of x is above the m of x. So they're 2 units away from each other when x equals 0. By the way, if they'd said when does m of x minus h of x equals 2, it would be all of this, because forever and ever and ever they're going to be equal by 2. All right, so determine the average rate of change of h of x and m of x from 2 to 5. So from 2 to 5. Well, h of x, or m of x, is just a line. And because it's just a line, the average rate of change for m of x, so for the m of x, the average rate of change, the arc, average rate of change, average, AROC, the AROC, average rate of change. I don't know if you can see that. The average rate of change for m of x is whatever the slope is. And so m of x, the slope is 1. So is equal to just 1. And I'm not going to go through that math because that's pretty easy. Now, let's take a look at h of x from 2 to 5. From 2 to 5, oh, that's just a line as well. And that slope of that line is also 1. So the average rate of change for h of x over that same interval, average rate of change, is also 1. All right, I'll be back, kids. I'm going to sure my big head's out of the way. Okay, how many of y'all, let me just highlight this in yellow because this looks crazy. I don't know what that thing is. That thing is just out of control. Oh, it's gone. I don't know what that's for. It was there before, and then it crashed. So hopefully nothing's not going to crash. So how many of y'all look at this and go, what are you talking about? That's crazy. Crazy. But that thing there, that just describes this function right here. It's equal to 2 for that interval. It's equal to negative 2x for that interval. By now you should be getting good at piecewise function. We've done 2 days of them. For that interval. And finally, that for that interval. So it's not a big thing. All right, so let's get started. Let's see what we got. First of all, I'm going to label these things. This is p of x, so I can see what's going on. P of x. Grab a different color. We'll go. And this one here is going to be, what is it? N of x. All right, so let's see what we got. For what values of x does, got a mistake here. I got to fix this before you guys see it. So hopefully when you guys see it, you'll see that I don't have a mistake there. Got to put that there on my thing, on my sheet there to fix. Let's see. This should be, what we got, n and p. So n of x equal p of x. Well, they're equal when they intersect each other. So when do they intersect each other? Well, they intersect each other here, and they intersect each other here. And remember, we're looking for the x values. So we're gonna, because there's 2 of them, I'm going to put them in curly braces. And we're looking for those x values. So x value of negative 1 and 3. Perfect. When does n of x equal 1? Well, n of x is the absolute value function, and that's the one we did in black. So when does n of x equal 1? And remember, this is when the y values are equal to 1. Okay, so we want to know, we want to find the x values, but we only want those x values when y is equal to 1. Well, y is equal to 1 here, and y is equal to 1 here. Notice if I drew in this line right here, this is where it's 1. Right? This point right here is 2, 1, And this point here is negative 2, comma 1. So my two answers for this one are negative 2 and positive 2. All right, moving on. For what values of, let me get rid of my mess. What values of n of x, what values of x is n of x less than? Okay, so since it's less than, we're looking for when it is below. Now, n of x is the black. So what we're looking for is when is black below gray. All right, so when is black below gray? Now, do you see it's below gray here? And it's also, wait, that's it. That's the only time it's below gray. So, it is below gray, and I can only use this interval right here because I don't know what P of x is going to do past that. So I'm going to use this interval right here. So from this interval, black is below. So I'm going to say from bracket negative 3 to negative 1. But now I can't put a bracket on the negative 1 because at this point they're equal to. So I can only put a parenthesis there. Perfect. All right, anytime they're asking about subtraction, they're asking about how far away they are from each other. So I want a positive value. So since I want a positive value, n of x has to be bigger than P of x, or n of x has to be above P of x, or black has to be above gray. So we want to know when black is 3 units above gray. Again, if this was negative, we'd want below, but it's positive, so we want above. So let's see. They're equal here. This is black is above 1, 2, 3, right here. 3 units. So I know for certain at 0. There might be another one. 1, 2, 3, 4. Nope. 1, 2, 3. Oh yeah, here look. 3 units above. So there actually is 2 answers. 0 and 2. And finally, the average rate of n of x and P of x from 1 to 2. Okay. So the average rate of change of n of x and P of x. So let's do n of x. N of x from 1 to 2 goes here. So what is the average rate of change? In other words, what is the slope of that line right there? Well, the average rate of change, the AROC, average rate of change of n of x is equal to negative 1. Now for the average, the AROC of, what is it, P of x is equal to, now that's from here to here. Now that's a horizontal line. Okay, if you got to try to remember, a horizontal line has a slope of 0. All right, example 3, all done. I'll be back. Gonna save this up. You caught me drinking again. No, not drinking like drinking. Drinking like drinking my delicious Dunkin' Donuts coffee. You know, I have had students in the past blame or claim or whatever that there's more than coffee in there. No, there's not. Nah, I don't drink. Not at 6 o'clock in the morning. I don't drink at all anyway, but certainly not at 6 o'clock in the morning. That's crazy. All right, you try it. Oh my God, look at that. I didn't even give you the graph, and I said you try it with a smiley face. By the way, if you're doing this now would be a good time to just pause the video, see if you can create the graph. Can you do the graph all on your own? And then come back and then hang out with the homie and see if we got it. I'm your homie, good. All right, so I'm going to do R of X in, what color am I in? I'm in orange. Orange is kind of an ugly color, even though it's my brother. I have a twin brother, by the way. Yeah, he's the ugly twin, if you can imagine that. Yeah, we had to tie We had to tie a stake around his neck just so the dog would play with him when he's young. Just saying. Sorry, bro. Love you, man. All right, let's see what we got here. I'm going to graph r of x using orange, 2x minus 1. So there's negative 1. I'm just kidding. No, positive 2x. So we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Anybody tired of me saying that? Up 2 over 1, down 2. We're going to go down. Down 2 over 1, down 2 over 1, down 2 over 1. Okay, so I only want the points where, for this one, that x is less than or equal to negative 1 or positive 1. So there's where x is equal to positive 1, and it's equal to, so solid circle, and we're going to go in. That's not too bad. This direction. So I don't actually need these points, but I put them on there just to see. Okay, now we're going to do the other one. 3x plus 1. Oh, it's still going to be an orange. Now we're going to do up 3 over 1. And I know that I only want the ones that are greater than 1, so I'm not even going to bother to go in the left direction. I could go down 3 over 1, down 3 over 1, but I don't need those. In fact, I don't even need this point right here. I just needed that as a reference. All right, so it said greater than 1, so what I need at 1 is an open circle. So instead of having that as a closed, circle, I need that as an open circle, and I'm going to go in that direction. All right, let me grab a different color. Grab this crazy blue. So this one I'm going to do crazy blue. Now, if you remember the work that we did before, I hope you do. If you don't, you can always type this in your calculator, but I'm going to not do that. The vertex is right here, right? We've done some transformation work, so that means we're moving our vertex from the origin. Remember, it starts at the origin, 0, 0. And because that's a plus 3, we're going to go to the left 3 and up 5. So 1, 2, 3, 1, 2, 3, 4, 5. And the slope is negative 2. So that means in both directions we're going to go down 2 and to the right 1. Down 2 and to the right and left 1. Down 2 and to the right and left 1. Let me just finish this one. I got to concentrate like crazy on that. And then down 2, and then down 2, down 2, down 2, down 2. So it should, oh, this is going to be rough. Hey, that worked out pretty nice. Okay, so that's our graph. That's our graph right there. So let's now go, let's start hang up. That's all, folks. Oh, I should label these suckers. So this one is u of x. And the orange one is r of x. R and u. You are great. You are a fantastic kid, student, wonderful. All right, let's keep going. All right, when do they intersect? Well, they only intersect at one value. It's right here, right there, and that's when x equals goose egg. So 0. By the way, you could just do this. 0. When does u of x equal 3? Now, u of x is the blue one, and we want to know when it equals 3. That's when the y value is 3. Here's where y equals 3. So I'm going to come over to my graph, and I said, oh, it equals 3 here, and it equals 3 here. What are my two x values? That would be negative 1 and negative 3. Huh? This would be negative 2 and negative 4. Somebody can't count. Negative 2 and negative 4. Good thing I have my answer key here. I'm checking my answer key along with while I'm doing this work for you. Okay, here we go. When does r of x greater than u of x? Now, r of x is in orange. So when is orange above blue? When is orange above blue? Orange is above blue. Well, here's where they're equal. And if I go to the right side, this side isn't orange above the blue. So anytime I go to the right-hand side of this, orange is above blue. So I would say when x is greater than, not equal to, but greater than 0. Another way to say that in interval notation is 0, infinity. Either one will be acceptable. All right, the next question says, when does u of x minus r of x equal positive 4? Or in other words, u of x is blue. So when is blue 4 units above orange? All right, so I got all this extra stuff here. Let me see if I can get rid of some of it. When is blue 4 units above? Blue 4 units above. I can never find my black pointer. There it is. It looks like it's right here. Right, 1, 2, 3, 4 units. So that would be when x is equal to -1. Or I can just put -1 in curly brackets. And then the average rate of change for u of x, darn. All right, so the average rate of change for r of x and u of x from -5 to -3. So where is -5? 1, 2, 3, 4, 5. So from here to here. So from here to here, that's just a line. And that slope of that line right there, the slope of that line right there is up 2 over 1. So the average, the AROC of, what's that, u of x would be 2. Now let's check the AROC for r of x. Man, r of x is going to be down here somewhere to here. But this is also just a linear function right here, and the slope of that line is from, that would be this one, because it's the portion where it's less than 1, and that would be also 2. So the AROC of r of x is also 2 over that same interval. So they're both 2. All right, kids, I'll be back. I know I got to stop saying that. You're getting tired. Whew. This 1.8 is a long day. My guess is your teacher ain't getting through all these problems in class, and they're probably sending you here to finish the notes. But that's okay. That's what I'm here for. You get to hang out with me. You're like, oh, I like hanging out with Mr. Krause. He's cool. Okay. You need a help. So let's see if I can get through these a little bit quicker, a little bit faster, but not too fast that I bore you to death. But you could always fast forward. Like right now, I would pause it, graph these things, fast forward, see if you got it right. If you didn't get it right, go back and see where you might have made your mistake. Okay? Now you can pause it. I'll make a funny face for you. All right, those were 3 funny faces you could have paused it at, but now I'm back. All right, so v of x is equal to 2. Let me get back to a different color. I don't like orange. We'll go red. So v of x is equal to 2. Since this is just 2, that is a constant 2. That means it's a horizontal line like that. There it is. Wow, that's really exciting. There's v of x. This is a absolute value, and the vertex is sitting right there. We're going to go 1 unit to the left and 2 units down. And my slope, we're going up, is 1/2. Over 1, up 2. 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 Somebody punch that bald man in the head, because he is really annoying. All right, there we go. Hopefully you graphed it correctly, and let's fly through these. When do they equal each other? They equal each other here at this point, and equal each other here at this point. So this is negative 7, and this is 1, 2, 3, 4, 5. So negative 7 and 5. Make sure you're using curly brackets. If you use parentheses, that means from negative 7 to 5. We don't want that. If I use square brackets, that means from negative 7 to positive 5, including those. You got to use curly brackets. It appears as if I might have made a mistake. Yes. Yes, I did. Son of a so-and-so and such and such. You're probably thinking to yourself, I'm here to get help from you, and you making a mistake? Oh, it's so embarrassing. I hope you all saw it when I did it and were laughing, screaming at the computer, you're an idiot, Krause. Why don't you be nice to me? It was over 1, down 2. So up 1 over 2, up 1 over 2. It makes it slightly different. There we go. Should have checked my answer key before I kept going. All right, so marine, it's actually this one and this one. So I apologize if you erased your work and then came back and all right, so anyway, these answers are negative 9 and positive 7. Those answers should be. Sorry. When does W, I didn't label these things. Oh, wait, well, yeah, I labeled that one. So this is W of X. When does WX equal positive 3? It equals positive 3 here. And it looks like it's going to equal positive 3 over here somewhere. Where is that? Like negative 11? So at negative 11 and 9. V of X greater than W of X. When is V of X bigger or above W of X? Well, when is red above blue? So red is above blue starting here and going to here. So where those points of intersection. So, but you can't include those. So we're going to do negative 9 2, 7, parentheses. Make sure you use parentheses because you can't include them. Because if you include them, that's where they are equal to each other, not greater than. When is their separation equal to 3? When are they separated by 3 units? And V of X is red. So when is red above W by 3 units? And I'll bet there's more than one place. Looks like right here it's 3 units. And it looks like 1, 2, 3. Right here, it's 3 units. So at negative 3 and positive 1. Yes. And then their average rate of change, again, that's just slope. Average rate of change for these is just going to be slope because they're both really linear functions. V of X, where the heck is V of X? V of X is a horizontal line, and the average rate of change or the slope of any horizontal line is 0. And let's see, W of X. W of X from negative 5 to positive 5. Now this one's going to be a little bit tricky. So we got to go back to our formula. So I'm going to do this one over here. Remember, this is going to be W of 5 minus W of negative 5 all over 5 minus negative 5. And this is just 10. All right, so what is W of 5? 1, 2, 3, 4, 5. It's right there. It's 1. What is W of negative 5? 1, 2, 3, 4, 5. It's right there. It's 0. So this is 1 minus 0, which is 1, all over 10. So the average rate of change from negative 5, so the average rate of change for W of X over that interval is 1/10. So for linear functions, it's just the slope. For piecewise functions and any other type of function, you're going to have to use this formula right here, where you take the functional value at one point minus the functional value at the other point. It's just That's what you got to do, kids. There it is. All right, I'll be back. I know. Stop. We've got 4 more problems to go. Holy crap, we're going to be here all day. Anyway, I'm glad you're back and sticking with it and helping me out and checking us out. Let's go. Ooh, this one was graphed already for us. That's nice. Let's go. Let's do this. I don't know which one's which, so let's see. Well, obviously this is b of x because it is a horizontal line at 2, and then this must be a of x. All right, we'll quickly get to this. When do they equal each other? Right there at -1. Boom, not a problem at all. When does b of x equal 3? Well, b of x only ever equals 2, so no solution. When is a of x greater than b of x? In other words, in layman's terms, in color terms, when is black above gray? Here's where they're equal, and anytime, so right here at -1 they're equal, and anytime I go in that direction, nice arrow, a of x is greater than b of x. So I can just do -infinity to -1, or I can just say x is less than -1. Either one of those would be acceptable. When are they separated by 2 units? Now, and a of x, black, has to be above b of x. And by 2 units, wouldn't that be right here? A of x above, so that'd be -3. And finally, the average rate of change. Since these are both linear functions, their average rate of change are just their slope. So I'm just going to write them right underneath here. For a, it will be -1. And for a horizontal line, it would be 0. So their average rates of change would be -1 and 0. The graph below shows the temperature in a pottery kiln. While firing a piece of pottery, a kiln is preheated at 200 degrees. On the same set of axes, graph 200 m. So that means it's got a y-intercept of the origin. And 200 m. So go over 1, up 200. Go over 1, up 200. Go over 1, up 200. The graph below shows the temperature in a pottery kiln, TMM, while firing a piece of pottery up the kiln was preheated to 200 degrees. The same axis. Well, I'm a little off with my gray graph, but that should be there. So it just, my gray line is not exactly on. It's a little bit off. Anyway, there's that graph. Okay. When does what is for value does T of M equal M of N? 6. When does T of M equal 1,000? Oh, well, first of all, T of M is this one, T of M. Now, this is P of M. And I should do this one in a different color. I don't have gray. I used to have gray. Gray was so boring, I got rid of it. T of M. So when does T of M equal 1,000? That would be right here at 4 for X equals 4. For what values of X is T of M greater than P of M? Well, it starts out greater here, and it's always greater until they equal each other, which is right about here at 6. So we're going to go from 0 to 6. Not including 6, because that's where they're equal to each other. When is there separation by 400 units? Looks like it's, let me just erase, but it looks like it's right here. And we want T of M above P of m. So that's going to be right, lost my pointer again, here. Between here and here, it is 400 units. So that would be at 2. T of m minus P of m. T of m minus P of m equal 400. All right, and finally, the average rate of change for T of m and P of m on from 0 to 9. Okay, so for the linear function, that's easy. That's P of m. So the average, I'm going to do this off to the side here. I got to get a different color. I can't see. So the average rate of change for P of m, because it's just a linear function, is just 200. But the average rate of change for T of m is a little bit tricky. So the average rate of change for T of m is going to be T of 9 minus T of 0 all over 9 minus 0. Well, the denominator is just 9. That's easy. But T of 9 is right here. That's 1400. Minus T of 0, 200. Oops, 200. So that's 1200 over 9, which I know reduces to 400 over 3, which is just really 133.3 repeating, really. 400 over 3 would be fine. So there's your average rate of change. All right, those two problems didn't take too long. All right. Oh yeah. By the way, that one took this one took so long. I almost had to go up and get another cup of coffee, and my coffee is already cold. That's how long this video is. So let's see. We got 5. Oh, good. They're graphed for us. The graph below shows the area circle A of R based on the radius and the circumference C of R based on its radius. Determine the following. We probably should label these things, shouldn't we? So the graph below shows the area of circle R based on its radius and the circumference C of R based on its radius. Well, area is a square unit, so this one would be A of R and this one would be C of R. So the question says, for what radius approximately will the area and the circumference of the equal? 2. R equals 2. What is the radius when the area is 50? 4. When is the area less than the circumference? Well, that would be from 0 to 2. We can't include either of those, so 0 to 2. Not including either of those. And then the average rate of change. Now, C of R is easy. Excuse me. It's just the slope. We just got to figure out what that slope is. And since I didn't give you the equations, you got to figure out what that is. So the average, we're going to do the average rate of change in the easy one first. So the average rate of change for C of R is equal to, let's see. Let's pick 2 points. Not 2 easy points here. Approximately. Wow. No real easy points. This is probably the nicest point. All right, so what we're doing, we're not going to use those points. I just had a brain cramp for a second, and I had a cramp actually in my foot, but a brain cramp. So what we're going to do is you got to think about circumference. Circumference formula is equal to 2r times pi, or 2 pi r, and the area formula is radius squared pi. So if we want to find the average rate of change from 0 to 5, what we're going to do is we're going to find C of 5 minus C of 0 all over 5 minus 0. Well, C of 5, radius of 5, so if I plug in a radius of 5 into that formula, over here I get 2 times 5 times pi. So that's 10 pi minus 0, actually, all over 5. So that's 2 pi. Hopefully my big head's not in the way. And then the average rate of change, I'll start over here for this one. Average rate of change for area of R is going to be A of 5, area at 5, minus area at 0, all over 5 minus 0. Well, the area of a circle that has a radius of 5 is radius squared pi is 25 pi minus 0, all over 5 minus 0, and that's 5 pi. That was a tricky question right there. That was a tricky question. All right. Last problem. Here we go. A flash drive, some sensitive information is falling on top of the building. Distance between the flash drive and the... I think I don't mean sewn here. I think thrown. Oh, shown. I missed an S. Shown. I want to make sure make my corrections. Yours probably says shown. Mine says sewn. But we want to graph f of t. So what I've given you here is d of t. I just wrote it kind of far away. D of t. And then I'm going to graph f of t, which is just 500. That's that horizontal line 500. This is f of t. And I really shouldn't... Well, anyway. All right, so for what values are they equal? 4. When is d of t black or gray below f of t red? So anytime after 4, but we got to end at 7. So from 4 to 7 bracket, it's below. And finally, on the average rate of change for d of t from 0 to 7. So we're going to do d of 7 minus d of 0 all over 7 minus 0. So d of 7 is 0 minus d of 0, which is, it looks like it's about 750. Maybe it's a little bit more than that. Do they give us an equation? Here's halfway. So it's like, I'm going to go 7. Let's go 770 for fun. You could make up a small number, different change. 7. You'll see why I picked 770 in a minute. And then 7 minus 0 is 7. So this gives me negative 770 over 7, which is negative 110. So there's my average change, approximately average rate of change, because they didn't give us the function name for d of t. Okay, kids, that's it. Woo! That was a long one. All right, hit the subscribe button, hit the like button. Don't give me a comment on how long that is or how ugly I am. I don't really care. You could say how good of a singer I am. Goodbye, kids. Catch you on the flip side.